Our next speaker is Elke Van Nieuwenhuijzen. Spell it for yourself.
I know how to spell.
Elke. Her topic is in situ detection of product age and argon concentration as measure of the reuse potential of insulation glass in buildings. Elke is currently working at the Applied University of Amsterdam, doing research within the project reused insulating glass. So her motivation is, if we now collaborate and develop sustainable solutions for the production of building materials, we may limit the shortage of building materials and excess of CO2 emissions. So it fits very well to the discussions we have these days. And please enjoy the presentation. Okay. Thank you.
Thank you. So, indeed, it's a lot of light. Good to see you all. Oh, it's getting cozy. I will be a bit slow so everybody can sit. Yeah, this is the last session for the farewell party, where some of you, I've heard, will completely go wild. I'm so curious. It could be you. It could be somebody else. I don't know yet, but something will happen. But before we go to that point, first I would like to have some concentration of your side on my presentation, because I would love to have some feedback. The research I've done that I present here today is about the in situ detection of product age and argon concentration as a measure of the reuse potential of IGUs in buildings. So the outline is pretty straightforward, but I do like to stress out that I will show only some results, some measuring errors that you can occur, and briefly go into the proposed method and the future development. But if you want to know more, then please be a few days more patient, and there will be a paper in the Journal of Glass Structures and Engineering. So, yeah, the introduction part, of course. Why would we do this? Of course, everybody will agree that glass is a fantastic product, and glazing especially. And multiple people stressed out that it has a good thing, and that is that it will supply light. Ironically, in this building, we did not have that a lot, but well, normally we appreciate it very much. And of course, the limit of heat loss. Therefore, also, because of that aspect, in the old days, we used to have like single glazing, but it's now off the market. Everybody uses insulation glazing. Also, in Australia, I heard that's also now common. So typically, but this is also, of course, especially then for the Netherlands that I'm mostly focused on, but probably more countries as well, this is a commonly applied product. So double glazing with a U value around 1.1 or between 1.1 and 1.2, and made of 2 glasses with argon in between and a low E coating on position 3. However, the drawbacks have been stressed out along this conference. So I will, I don't have to go into that too much detail. So you do know about the negative aspects. But then on the second point, I wanted to say a bit more, because I was completely focused on the EU. But we had a night lecture yesterday morning also about North America, so there's also things going on, also some actions, but if I understood correctly, there it's more the carrot than the stick. So in Europe, it's a lot about the stick. But also in Australia, things that are also going on, but that's, if I know correctly, also the carrot and not the stick. And then the idea to solve the problems of the drawback is the circular economy, which is a theory. And the theory is that the higher the level of circularity, the less environmental impact material used. And currently, as has been said in many presentations, the IGUs have now a low level of circularity. And then, like the examples that were mentioned, that it's used for landfill, or that it's used for insulation or for bottles. And everybody knows, once you become a beer bottle, you will never become glazing again. So that's something we have to do with it. However, there are examples of high-level use of post-consumer window glazing. And I will give some examples, and then related to this nice ladder of circularity. We also saw many of those ladders. They're not always the same, but more or less they are. So we have, this is an interesting one, we have the remelting of post-consumer colors to make flat glass. And what I understood was that Saint-Gobain had made a project to do 100% reuse of post-consumer colors. And then afterwards, like this year they released, or maybe last year, they released a wonderful product of Orae, pronounce it correctly. So then I thought, oh, that must have been made by post-consumer colors. But now I'm not so sure, because I talked to a lot of people of you. So it could be that it is not post-consumer, but I could not find it very clearly if it is or if it's not indeed. And then I have to mention, so here I put then Saint-Gobain, who did something with post-consumer colors. But if we want to say, they do have then the product with a lot of reused colors, but then internal or external, but then still pre-consumer. But AGC, of course, has a product now as well on the market, but they're not shown there. And if we go a level higher, then we go to IGUs that are made of old uncoated glass together with new virgin coated glass. So that example is on the market today. GSF Glass Group in the Netherlands is producing that. That is an interesting way of going, but we also wanted to look up if it could be even more circular. And then people are saying, yeah, but you can also repair or upgrade IGUs. I do know rumors that are people that are doing that, but I do not know real the companies and if it's really then in production or how much it happens. And another example is the reuse of insulation glazing as a whole, so that you reuse the total package. And there are examples of it. For example, this is from Bureau Sla. It's a pavilion in Amsterdam, in a park, very lovely, but it is an incident. So it's not that it's very commonly occurring. But now that we know all those examples, then also the question rises, if I have an old IGU, what should I do? So where should I put it? And that comes to the research objective, that in this study we would like to develop a screening method that to screen the high-level reuse potential of double glazing in buildings, so that you first screen in a building what can I do with it, which is based on IGU age and argon concentration. And why then the IGU age? Yeah, that's because that you can have an indication of how long the IGU will still be there in a good quality. And the argon concentration is also because then you have an idea how much the U value decreased or how good the sealing is performing, and also because you can measure it. Because if you want to develop something, it's nice if you can measure it. So this is, over here you can see the Sparklike device that we used to do measurements to measure the argon concentration. And I did that together with a PhD student from the Vrije Universiteit België, Esther Geboes. And this Sparklike device is based on spectrometry. And if you want to know more, please go to Antti is there in the room or somebody else if you're really into kinds of spectrometry. For me, it comes down to it does measure. And what does it measure? It measures the glass thickness, the cavity thickness, and it measures an oxygen concentration. And from that point, the machine calculates the argon concentration. Not exactly the argon concentration, it calculates the gas concentration, but I presume in most windows there is argon and not something else. After that point, we try to get the average values, but we did it, before we did it, we first looked at if you can find some outliers based on the glass thicknesses and the cavity width. And then furthermore, we also did some measurements on the glass thicknesses and cavity width with the glass check Elite, just to make sure what we were, to have a double check on the thicknesses. And then we tested double glazing. Those double glazing were either in a building, so in use, or it was a tested, defined test, and that we did at a factory of Ben Evers. And we studied various influence factors, because I don't know how many people of you have ever used the Sparklike, but there are some things that you can imagine in front that it will have an effect. So we try to find and to see what will happen. So this is an example of one of the results that I show you. We measured in a building one single IGU, and we measured it multiple times. But after the first session, the machine shut down because of a lack of electricity. So then I thought, well, let's start again. So session number 2 is right after the shutdown. So it was now connected to the grid, of course, because it needs electricity. It was connected to the grid, but not checked and calibrated again. So just connected to the electricity and start measuring again. And then we found out, oh, but the measurements are much higher, up to 9% too high. So after that point, we thought, well, let's shut down the machine again, properly start it up again, and start measuring again, which gets you normal results. And to be really sure, do it another time on another day, and then you get those results. So the lesson is then, it's very important if you have something with an energy change, that you should do the check on the calibration check again. And then another example is also in a building. We measured several IGUs on 3 different days. And as you can see is that on the first day, which is the black things, that the values are much higher. They are up to 14% higher. So we went back another time and another time, and based on that you could already see, yeah, then probably the first time was not okay. But also because there is one IGU amongst those which is very full of water. So there's in the bottom water and there is condensation. So then you would assume that your measurement would be around 1% argon. So there should not be a lot of argon in. So that made clear that the first one was a mistake and the other ones were okay. And a possible explanation for that, because we thought about it, how can it be, is that we did have an unnoticed setup error at the beginning. And therefore, we thought, oh, this is a good lesson. If we do the calibration check, please document it, because you can check later on if it went okay, and do perform one at the end of the day, because if you're measuring a whole day, then it's also nice that at the end of the day, it's still calibrated well. And then the last results that I show you, and then we continue to the other part, is that we did some repetitive sessions with defined samples, so that we really knew what we had in our hands. And the good thing about that was that we find out the margin of error of the argon measurements, and they fitted well to the declared information of the manufacturer. So that was a plus minus 2% at a 95% confidence interval. I won't go into the statistics, but if you're interested, please come by. And next to that, the average front glass thickness that we, and the cavity width that we measured with the Sparklike did fall in line, was similar with the elite results and with the product data that was on the IGUs itself. So then I come to the proposed screening method. So if you want to screen an existing IGU in a building and you want to think, can I reuse it on a high level, then first obtain the IGU age. That can be done, for example, I'm not sure if there's a pointer. No, it's no pointer. You can, for example, look for the codes. Most IGUs have it, and if not, have a talk with the manager of the building. They mostly know when it's renovated. Next to that, do the argon concentration measurement, and you can use the Sparklike laser portable for that. It's a good instrument, but then frequently check if it's still well calibrated. Check out outlying data, it's an important step, and then determine the average argon concentration. And then if you have that, select the recommended strategy. But before we get there, we need to have some thresholds. And the thresholds that we set was for the product age 15 years. So you need to have an IGU that is 15 years or younger. And why did we select that one? Because in the, I have to look at the number, sorry, EN 1279, there it said that an IGU is assumed to be performed very well for 25 years. So it's not saying it's then broken afterwards, but it's saying it should perform well for 25 years. And if you have like then an IGU that's 15 years old, that at least you know it will well perform for another 10 years. Next to that, you have the technical lifespan, of course, and which can be even longer. If you're unlucky, shorter, of course, but that's another discussion. And other benefits, if you have like IGUs that are 15 years old or younger, is that at least in the EU, that the CE 2007 was already in place, so that the quality of the IGU should be okay. And you will not encounter galvanized steel spacers, which is good in terms of energy. And it's also very unlikely that you will encounter IGUs with bad performing or non-coatings at all. The other threshold is the argon concentration, and if you want to reuse IGUs as a whole, that is set at 85%. And why? Because in the norm, if you have a new product, mostly it's 90% filled, and then it can, of course, to reach that value, you can have an actually concentration of 85%, so you have a margin to get there. And this should, reused IGU should have that one as well. So if we then look at the different recommended circular strategies, you can see that I'll walk through this one, that here you see the IGU age, so it's 1 to 15 years, and you have an above or equal to 85% argon concentration, then direct reuse of IGUs, or even upgraded with an extra glass plate, is recommended. Are you below 85%, but it's still 1 to 15 years old, and it does occur, then it's not recommended, and then it's recommended to disassemble the IGU pane and reuse it, or to make cullets of it for flat glass. And if it's older than 15 years old, the IGU, it's not recommended to reuse it directly, but also to disassemble and reuse the glass pane or recycle it. Of course, if you have an IGU that has some fogging inside or is broken, of course you don't have to do the argon measurements. You already know it's not wise to reuse it as a whole. What I proposed was just a first attempt to have a screening method. I do expect some adjustments in future. This is, of course, just a start. And there are some recommendations to improve. You could think of that you want to know something about the spacer. You have different kind of spacers, and I will do something also with the U value, but then of the, not of the U value of the glass, but of the total. You could include looking at the quality of the coatings, and there might also become new or other devices to measure, and that then you should also incorporate that. Or what also could be, if there will be an area where you collect all the IGUs, so we live in a different world and all IGUs are always collected in some place in an industry, then it's more easy to measure, because then you don't have to go to the buildings and measure them all there. And now I come to the conclusion. A method is developed to screen the high-level circular use potential of double glazing in buildings based on product age and argon concentration. And there are 3 categories of high-level circular strategies suggested, and each have their own threshold values. And the Sparklike Portable is a suitable method to measure argon concentrations in situ. And also, if you want to avoid measuring errors and you want, then use a specific handling procedure and data check procedure. I would like to thank a lot of people. Some people are in the audience, I see. Thank you very much for your help. Because I did not do this on my own, of course. I did it together with colleagues, with partners, with whom people had time and the willingness to help me. So that is really nice. I hope we can continue that way. And if you have any further questions which are not able to be answered now, please do not hesitate and contact me. Thank you.